All right. So I've got some news articles here. I must say I heard a good podcast from a news source a few hours ago, and I must agree with them that this impeachment thing is amazing, and it blocks out the sun. One thing I think you can say with great confidence is nothing else is going to be accomplished in the U.S. government for months. This is the big thing. Nothing else could possibly matter. And this is, of course, the big issue. I was just amazed, even at this distance, to see how Trump tried to block the report, and then it came out, and then he tried to block the whistleblower complaint, and it came out. The whistleblower complaint and the partial transcript both came out, and what a storm. It reminds me very much of the Richard Nixon times. And the thing I always thought that was going to save Trump is that, unlike Richard Nixon, he didn't make recordings of everything, which would then leak. But he did make recordings, which have leaked. So, you know, this might be the end of him, although there's no possibility of an actual impeachment finishing. But the thing I'm hoping is that this might actually wake up the Democrats. I mean, the Democrats could easily outvote him if they bothered to get out of bed and vote. The problem is only half the Democrats vote. The Republicans, who are much more enthusiastic, win because they all go out and vote because they feel very abused and they're very determined that Trump is a great guy and all this picking on him is mean and unfair. They really feel that strongly, and the Democrats don't seem to actually care. So anyway, this is the argument. A lot of people say you shouldn't impeach him because the Democrats cannot possibly be stirred from their slumber, and the fact that you won't win means nothing good will come of it. We will see. But I'm very interested to look at it, especially in world terms, because there are just fundamental differences in what the government should be. And it seems to me like the Republicans are hearkening to an older model of government from the Middle Ages, where you have a king and he can do anything he wants. There's no laws restricting him, and you totally trust him and are loyal to him and have an emotional love for him and hate anybody who would dare to suggest that there's anything wrong with him. And that's the model they want. And the Democrats have this lawyer system where you have a bunch of laws and rules and procedural policies and such. And of course, both of them seem to be riddled with corruption all the way through. And we will see what comes of it. But I think there's just a big turning point of America that we're living through. And so, I'm just amazed how much we're in lockstep with Britain. So Trump said after this that we ought to just get rid of the spies that leaked the information about the whistleblower report, which he thought he had suppressed, and treat them the way we used to treat spies, suggesting when we used to just kill them. And the New York Times leaked out information about the whistleblower's identity. So this may lead to the whistleblower being punished to some extent. And across the pond in Britain, the same thing happened. Boris just is using harsh language about the people that are opposing Brexit. So the women in Parliament are getting daily death threats and rape threats if they oppose Brexit. And they're telling him to stop calling them traitors and talking about betrayal of the country and selling it out to Brussels. And just like Trump, he's saying, shut up, I'm going to say whatever I want. And you people really are traitors and you deserve all this punishment. It's sort of spectacular. The same nonsense on both sides of the pond. We're both at a crisis. Anyway, and another big issue is the rising of mythology on both sides. And you can see it in the vaccination. Both Britain and America are now having measles outbreaks, and people are refusing to take vaccines because they just believe mythology. Like Trump believes that the security firm CrowdStrike somehow comes from Ukraine, which they don't, and somehow took Hillary Clinton's email server and hid it in Ukraine, and the president of Ukraine can get it. And this is all nonsense. Like most of what he says, he just made it up. It's a complete fantasy. But the people on the right pretty much believe all this fantasy stuff and live in a different world than the rest of us. And it is a very strange system. Like I say, it makes me think of the medieval days when the king was chosen by God and you would all worship him and anything he said is right. And that has been a very popular model for human government, and we seem to be going back to it. Anyway, see if anything else good in the news here. Here comes a comment. What time do you normally log in? Well, I start the Zoom just a few sessions before class. I started it maybe 10 minutes before class, and I always try to make sure class start, and I'm connected either in the classroom or remotely by 6, and so I can talk about news for about 10 minutes before the lecture. So I hope that helps. Good.
What time is it over there?
It is 6:30 a.m. over here. It's just 12 and a half hours away.
Okay.
But I'll be back in San Francisco next week. So let's see. This one here is kind of fun about Google. And yeah, looks like Jewel is out. The French government passed a rule that, here, let me see if I can detect a source of noise. Okay, I guess we're all right. So I heard about this a while ago. The French publishers believe that they should get paid every time Google lists their articles. If they show like the first sentence of an article and you can click on it to view it, they feel like they should get paid for that. Google doesn't agree. So what they did, they actually passed into law this copyright restriction that Google cannot even quote small pieces of the article as part of a search results. And instead of paying, Google has just removed those small pieces of an article. So French links will just have the URL and no further description, which is certainly not what they wanted. But this has been the European copyright issue for the last couple of years. They've been feeling like Google is exploiting them if they quote a few lines of a headline and put it in the search results, and there are ads on that page, then Google is getting money from just the headlines. And they don't seem to realize that if people click the link and go to the page, then they'll see the publisher's ads, and that would be their chance to make money. But anyway, the battle goes on. And this, I think, is part of the huge issue, also true of all social networks. As every country starts passing privacy laws and copyright laws and everything, it's going to become very difficult to run an international website and comply with all those regulations all over the place. So anyway, so we're here at 152. And we're going to talk about getting the investigation started and initial development of leads. All the quizzes should be up, and your projects should be up so you can do them. Let me know if you have any troubles. But I will proceed with the official material here. All right, so let me make this big. I'll probably just make it full screen for a while. I don't think I'll need to point at pieces of it until later. So to get your investigation started, you need some kind of incident occurs to start it all, like somebody has an antivirus product go off or something. And so then you're going to have some basic information you get by interviewing the original person that reported it that will give you something like IP addresses and times. One big issue for any large company is that you have machines at many different time zones. So the best thing to do is just use universal time on every machine for everything in all the logs. Otherwise, you have a lot of confusion adjusting it. So you're going to have an incident summary, the way it was detected, the details, and the network details. I think I'm going to mute the CNIT mic because I'm getting some noise here. But if you guys need to reach me, just send a chat message. Hopefully that'll make it more clear. Anyway, so you're going to need a lot of details about the incident to lead you forward. You should be aware, of course, that during a breach, you cannot trust any internal mechanisms like the company email. So you have to have some separate out-of-band system to document this, like a wiki kept on another server by the incident response team. And so you're going to have to record all these things, the exact date and time the incident started, who all the people involved are, who reported it, who detected it, and so on, and which incident handler, an incident responder, recorded things. Just like you do in police reports, you have a record of who did everything so you can go back and ask them questions later and perhaps have them testify in court as to what they did. So you describe the incident like it detected malware or phishing or something, then how it was detected and what was affected, unique identifiers of all the computers and systems and people, what you have done to find out who is involved, and how confidential this information is. Often you want to keep everything confidential for a while until you figure out what's going on and then have a carefully managed press release. And this, of course, is what happened to me when I reported security problems to people like the Bank of America and Chase Manhattan. It went in, they saw it, and people inside those companies were reading what I said and doing things, but nobody would tell me anything. So I thought they were totally ignoring me. And it wasn't until an unofficial leak through a deniable channel managed to reach me that I was able to find out that they were hearing anything at all. And that's typical in such a big company, because anything that comes out will affect their stock price and their business partnerships. And they can't just have technical people who don't understand business and legal consequences saying anything that would affect them. So to detect it, you're going to have some kind of detection, which you record, often through an automated alert. Then you have some information and sources. Then you have to validate it. This is something I always tell the students in the pen testing classes. If you run something like a vulnerability scanner and it says you have a vulnerability here, you can't believe that at all. Those things have false positives and they're wrong a lot of the time. So you have to come back manually and inspect it to decide if it's a real problem or not. And then you try to preserve the source data as much as you can. So find out who's running this detection source and how reliable is it, and has something changed. It's entirely possible that somebody just updated your intrusion detection system with new rules, and those new rules have new unfamiliar false positives, and that's fooling you, and you don't have the problem you think you have at all. So each system should have a unique identifier. That's why machines always have a label pasted on with a code number or something. So you know which machine it is, who uses it, the IP address, host name, and all that jazz, and whatever critical information is on that system. So you know, begin to get some idea of what damage has been done, and find out if it's still connected to the network, if the malware is still spreading, or if somebody has done something already to attempt to limit the harm. And then you have the network details. So you need to know all the external IP, if you can find them. If you can find command and control centers or attackers' staging centers, servers that are being used to perform the attack, that's extremely useful, of course, because then you can easily take your SIEM solution like Splunk and look for all the data that is sent from that IP address, and that will help you determine what the bad guys are doing. All right. And when we've got malware, then you need to know how it was detected, what systems it's on, file names, things like MD5 hashes. And if you are able to identify it with an antivirus list or something, then you'll have a name and family of the file and so on. And if you're lucky enough that the malware has already been analyzed, then you'll have some clue how it spreads, and you can know where to look for more. You should keep a copy of all the malware, and this is, of course, what happens to the advanced persistent threat actors like the United States and Israel. When we attacked Iran with Stuxnet, it was a failed campaign in some ways. It did succeed in shutting down the nuclear program in Iran for a while, but it was a failed campaign in that it did not erase all the traces, and samples of that malware eventually made it to the antivirus companies, so it became public. And that is, there were some previously successful campaigns like Wiper, and nobody was ever able to prove who launched that attack, because that attack would affect systems and then wipe the entire hard drive afterwards to destroy all the traces, and nobody was ever able to get a sample of it. So that's what a more professional campaign will do. But if you do get a sample of the malware, then of course you want to preserve it, and you may want to be sending it to third parties like VirusTotal, and you may not. You can take an MD5 hash of a sample and you can search for it on VirusTotal without uploading a sample, and that will not add it to the database. It will just tell you if it's already there. So that's a better procedure if you want to maintain operational security and prevent your attackers from finding out that you have discovered their malware. Whatever you do, you have to have case notes, and you should try to be professional and clear in them, because those notes might end up in court. I made this mistake when I was young at my incident at my escrow agency. I was working on databases, and I made notes, and I put jokes and unprofessional language in the notes, which got me some frowns from the boss, because I was unaware of the fact that that stuff might appear in court and be inspected by other people. I thought it was just for me to keep track of what I was doing. And so I learned this lesson the hard way. So you'll have notes like this at a certain date. and a certain time you get an infected email. Let me just go here and hit the mute all again. All right. And you find out where it is. Then you find something in the prefetch showing that a file, an executable file has been run. The prefetch folder lists all the executables that have run recently on a machine so they can be reloaded when it started. So then you find metadata, you find someone that sends, then here's the point where they'll call that security department to report it. And then here's when you went to that machine and collected some data from it. Notice they collected a live response data, which is what you usually do. You don't start by imaging the whole hard drive or the whole RAM. You just run some standard script which will record all the running processes, all the recently modified files, all the recently modified registry keys, and things like that. A relatively small list of data. All right. So typically what you want to find out is a small list of questions. You want to know who broke in, when it happened, what they accessed, and are they still inside? And I must say, who broke in is often not that important. You may not really care about attribution. You just want to find out what they've done. So if you're in PCI compliance business, then you'll need to know which account numbers have been compromised or credit card numbers, and you will have to consider the legal consequences. People may be copying your data or so on. But you may have people committing crimes inside your company. You may want to punish them later. So you have to make sure that management understands what you can do. And this is why one very important person on the incident responder team is the person that interfaces with your own management to help them understand what's happening and understand what they can reasonably expect. Often, breaches are not detected for months or years, and much of the data is lost. That's why the quality of an IR team is judged largely by how quickly you detect incidents and how quickly you resolve them. And when you are a new IR team, you are probably going to be very bad in all respects at this. It's going to take a long time to get good at this. So here's an example. Someone ran an automated vulnerability scan from outside the company. Then they entered through a management interface, which they found, being able to guess the password or otherwise get in. Then they started setting up a Warez site on here so that illegal files are being served through the company. Now in this case, management wanted to find and prosecute the attacker, but this is not worth the bother because this is a very common automated attack. That's how a lot of illegal and content is distributed on just mass hacked machines who are used until they get caught and then they move to the next one. So it's probably more realistic to just treat this as an ordinary virus attack sort of thing where you just patch the vulnerability, update your stuff, and keep going. Not that reasonable to expect to find out who did it and prosecute them or anything. So I should have cahoots someplace. And here they are. We are, it was chapter 4, so it's here. Okay. And we should have some sound. There we go. All right. All right, let's see, I've got 8 people. All right. And I know there's maybe 3 in the room. All right, I'll give it another few seconds. All right, gotta wait a bit. People are still coming in. All right, 5 more seconds. Okay. So which one of these is a false statement? Yeah, that's obviously the one that's rare. Most attackers are entirely outside the company, or it might be an insider doing something, but usually the conspiracy between outsiders and insiders is rare. There are cases, there's a case I worked in, well, a $2 billion fraud involving about 10 major grocery distribution companies, and there they had insiders and outsiders working together. But that was one of those rare, huge conspiracies. Most attacks are not that sophisticated. So which step do you not normally bother with for an individual system? All right, that might sound ridiculous, but this is what happened at the college when we had our crooked CTO and his crooked contractor that claimed we had a virus infection that was not true. Many people, including me, asked him to let us see the machines that were supposedly infected, and he said they were all unavailable because he locked them up for the FBI to analyze, and this is bloody nonsense. Even companies that work with the FBI, that's not how it works. He was frustrated by other things. When he went to RSA and tried to talk to FBI agents about how much I had abused him, he found out that those FBI agents were my friends and they knew me better than him. So in general, his plan to get away with this fake outbreak didn't work out as well as he had hoped. Anyway. So which detail is not usually important? All right, and what nation it came from used to be considered ridiculous, and recently it's not so ridiculous. We have the United States blocking Huawei hardware and blocking Kaspersky software, so we are beginning to take this more seriously, but in general, that's a smaller consideration. So it's M, Kino, and K, I bet, is Carla, and that's probably Abdul, Sam is sleepy. Let's see. Yep, good. All right. I'm getting to know the fake names. All right. So let's go back to the slides. All right. So leads in detective work, I know it from TV, leads are actionable data. You might have a bunch of information, but the leads are things that give you an opportunity for further investigation. So the identity of somebody that you might be able to talk to that would know more, some kind of network indicator that might lead you to other machines, or so on. So you have to find leads of value. A lot of information you find is not useful. So it has to be relevant. It's really associated with this incident and it's not just a random other thing. And it has to have enough detail and be actionable enough that you can figure out how to use it to learn more. So then you clarify the data, so you understand the lead, make sure that it is accurate, and get the context around it, and then you can follow it. So the most common thing, of course, this is what beginning security analysts are doing, is watching the intrusion detection system. They see alerts going by from Snort or Suricata or something, and they're seeing a lot of repetitive things, and they have knowledge of some number of these, like the top 10 that they know how to handle, and all the rest are passed on to someone else. So you identify the origin, inspect raw packets, look for other connections made by the host that appears to be involved. These are things you might do to try to follow that lead. veracity means making sure that the lead is in fact true, especially if humans are the source. This is one of the most common things happens to me all the time, and probably to a lot of you too. If you become known to people as some sort of computer expert, then a lot of people come to you and say, I've been hacked, and they have some evidence, which often is not very convincing, and it's really something normal like a malware infection or a misunderstanding of a configuration. So, it's an issue. A lot of people freak out, and they haven't really got a real security incident. They've just got something that fools them. So your goal is to turn your lead into an indicator. What you're hoping to do is analyze it to where you find something you can use that will really help you find the extent of the attack, like a network traffic signature or something of that sort. So there are property-based indicators with things like registry keys and MD5 hashes, mutexes, which I mentioned before. Mutexes are handles in the RAM of the machine, which are placed there to be seen by other processes so that the malware will be able to know that a machine is infected and not bother infecting it again. And therefore, it's a very useful indicator of compromise. You can run a live collection on that machine and detect the presence of the mutex and know if it's there. There are less specific leads like unexpected executables in a strange directory. This is what antivirus products call heuristic detection, and it is useful to detect new attacks where you don't have things like known MD5 hashes, but the problem is it's likely to be a false positive. There are other things that may not be part of the incident that would cause these vague things to happen, so you might end up wasting your time chasing down false positives. So you get some data from the initial lead, you then create some indicators of compromise, and then you go through a cycle of verifying it and checking that it's relevant and seeing if it's a common activity in your environment that's irrelevant, or if it's something that really indicates infection. And you have to go through a few cycles of refining the lead before you're ready to publish it. Publishing it means putting it in a system that will then be used to run a scan on your whole network to see how many other machines are infected. And you don't want to waste time doing that until you've carefully chosen indicators of compromise that are accurate and will not create too many false positives. So here's some examples of how to do this. You're trying to find something that will give you a clear read. This machine is part of the attack. This machine is not part of the attack. So if there's some malware sample from this book that they reuse in 126 that they decided to use as an example. And so these MD5 values I just typed in myself to make the slides easier to read. They're not accurate to that sample. But anyway, here's the simple one, the simplest thing an antivirus might do. Just look at the MD5 hash and that's it. And of course, the good thing about this is a low false positive rate. If the hash equals that, then you know to a virtual certainty that that's the right file. In principle, there are some MD5 collisions, but in fact, they're rare and difficult to achieve. And in practice, you don't have much possibility that an MD5 will match, and it's not exactly the file you expect to find. And if you're worried about that, you can use a SHA-1 or SHA-2. So that's the good thing about this, is you won't waste your time on a false positive. The bad thing is any modification in the file means this won't fire anymore, so you have a problem with false negatives. So you might look at the PE headers. Remember, Windows portable executables. All the files that run in Windows machines are in the PE format, and they have a header that specifies things like the compile date and the functions that are imported and other things. So you might use the MD5 or the exact time when this file was compiled and something about the size, and this might be able to detect some minor variations in the file. So that might be more general. Another one might be to look at the DNS cache. If you have been lucky enough to find a DNS name for the command and control center or some domain name associated with the malware, then you could look to see if that is in the cache. And that means this machine has been going to that website, and that probably means it's infected or been touched by the malware. So that's another way to go. Or you might have a service running with a special name associated with the attack, like Intranet Network Awareness, or so on. You can have a whole series of possible clues, and this might be better, that it will detect the malware even if it has been modified in some small way. So you're just trying to get enough information to reliably detect the file and not spend too much time on each machine. So you don't want to slow down the scanner with too complicated a logic path. which, by the way, is very easy to do with snort rules. All right, so the import table lists the libraries used by running the program. And so normal commercial software uses predictable libraries, and they usually use the high-level libraries that will do something like download a file with a single library call. Malware typically uses strange low-level libraries, like direct socket network connections and so on. So you might be able to just list the functions it uses. This does create service, registry, create key, read a file, internet open, and create process. And you might find a pattern of libraries that are imported, which is not something you'd see in a normal thing. So this is a signature that's more likely to survive an update of the malware. So that's there. Now, then the modern technique I mentioned before is to not use malware. Malware is a relatively old-fashioned, obvious technique. These days, people like to do living off the land. If you know how to use Windows utilities the way they are and Linux utilities, you can do whatever you want that way. And so here's one very common attack to hack into a Windows machine. If you want to bypass the login on a Windows machine, you can put sethc.exe and replace it with cmd.exe. Sethc.exe is used for handicapped accessibility. So if you are trying to log into a machine and you can't type on a keyboard very well, you press the Shift key 5 times and it will then open up the on-screen keyboard and other options. And that will have to launch with system privileges because it's running before the user has logged in. So if you can find a way to trigger this, after changing it to CMD, you'll get a command prompt with system privileges. And so this is an old trick to hack into machines. If you have physical access to them, you press the Shift key 5 times. But you can also do it by connecting it to the debug handler and then triggering an exception, which will cause the debugger to run. So those are 2 ways to use this after you've done the replacement. So if someone is using this technique to bypass login, then the simplest thing we can do is just look and see if they've been altering this file, sethc.exe. You just take the MD5 hash of the genuine sethc.exe, and if the file has a wrong hash or it has the wrong time date, then you can raise an alert. That's certainly one way to do it. The problem with that is, of course, as Microsoft changes their versions and puts on updates, Microsoft changes that file. So you'll end up with a couple of MD5s and a couple of time dates that you have to check for. And this is going to be burdensome to use across an enterprise as time passes and you have security patches and Microsoft keeps changing the alert. And this is an example of the more general problem I've come across before, that whitelisting sounds great. If you just listed only the good stuff that could run and nothing else can run, that would seem to be very secure. But the problem is keeping the list of known good stuff up to date becomes a very heavy burden for this reason, because there are updates and changes and new software and new versions until it tends to drive you nuts. So another way would be to find some more general clue for the replacement that doesn't require the sethc.exe to have exactly what you want. So in practice, people want to put CMD there, and CMD is always bigger than sethc. So a much simpler thing to do is just see if this file is bigger than it ought to be. And if it is, then raise an alert. And this is, of course, faster to run, faster to test, and more likely to survive variations in the attack. If you're using the debugging option, then you could look at the registry key, which is used for debugging, and if it contains sethc, then that will raise an alert. So that's a pretty easy one to detect. You can put these in formats. Mandia offers some software to automatically deploy tools. I haven't had much luck with Mandia Redline, which is the one I tried. It seemed to me like the most practical technique is to just write your own script with WMIC and command line windows, or in PowerShell, or on a Linux system in Bash. You can just write a script that probes for these things. It's pretty easy to do, and seems to be a lot easier than using these tools to try to make it simpler. But anyway, if you want to use a commercial tool, then they'll have a format for IOCs. And so you'll have this tree-structured way to just lay it out so you could then feed in an XML file of known indicators and put them in. Network-based indicators have been around for a while, so you'll look at a series of bytes in a file and see if they're there. I know the attack by a Muslim extremist group on American banks about 6 years ago, the Al-Qassam Cyber Army. They didn't like some videos on YouTube, and they decided, which I thought was kind of interesting, they somehow calculated a monetary value of the insult to their God and decided to punish America by costing our banks that precise amount of value. So they did DDoS attacks on banks until they calculated they had done enough harm. And every month that YouTube refused to take down the video, they would have another attack to bring down more harm. And anyway, one of the early versions of that, they just sent HTTP requests that had 100 capital A's in a row. So it was very easy to block. And every successive attack, and I think there were something like 10 or 12 waves of attack, they would get smarter and more clever at disguising their attack. So one thing that you could get if you went to security conferences, they had these sort of quiet talks that you weren't allowed to record that would release the latest indicators to stop the latest attacks. And they didn't want the attackers to find out that they'd been caught until as late as possible. So one thing people love to do is DNS monitoring, which is very much in the news now because the major browsers are all moving to DOE, DNS over HTTPS. Chrome and Firefox are both moving to it, and the British government has protested so strongly that Firefox has chosen not to distribute that feature in Britain because Britain just passed a big anti-pornography law. And so the whole nation has to have pornography blocked on the internet unless you supposedly register for some kind of people opting into the porn, and that system is not working very well at all. And they complained that they're doing that with DNS monitoring. And if you encrypt the DNS, they won't be able to block it anymore. So they're not going to distribute it by default in Britain right now. But anyway, you monitor, if you are using the normal DNS that is not encrypted, then every domain name you resolve is trivially sent over the internet with the DNS resolution and easy to spot. So it's just in the query name, and you'll find it here. There's a query name format. It doesn't have the dots in it. It just has a series of fields with a zero-length octet separating them. You can also see them in Wireshark, and Wireshark will let you see the actual bytes here. And if you look down at the bottom of this, you'll see this 03 here. That is not a dot. It shows up like a dot here, but it's a delimiter, 03. I think it just means there's 3 more bytes coming after it. Anyway, that's the, you get, I think this 18 is in hex, the number of bytes there. So this is old Pascal strings. This is the way Pascal made strings. First would come the number of bytes in the string, then come the bytes of the string. It's not null terminated, and it doesn't really have a dot in it. So that's a thing to know when you're writing signatures. And the standard for this for a long time has been Snort. This odd-looking format here is how you describe a Snort signature. You have this system, and it is the standard way to represent, store, and distribute network signatures. It's also very easy to get confused in writing Snort signatures and get them wrong, and it's pretty easy to make Snort signatures that use regular expressions and cost too much CPU, so they bog down systems. So it's a relatively high-skill activity to write good Snort signatures. Anyway, so now you can begin monitoring the network with TCP dump, load the malware in a machine and run it until it performs a DNS lookup to see, and then they put it in a phony DNS server. So they log all requests. This is one way to do it all, dynamic analysis. So they inspect both sides of it, where they not only run the malware the way we did and watch the network traffic, they also run a fake server to see what will happen there. That's another way to do it. Anyway, so after you've got your indicator of compromise rules, you then test it on some machines to make sure it does detect the compromised machines and to make sure that it doesn't fire on clean machines. So that's, of course, what you want. So here's another example. You send an email with malicious payload. That's a dropper, like a Word document. Somebody runs the Word document, and that, of course, drops another Word document and puts a second stage malicious file in there. The malware removes the dropper, and the second stage malware continues. That's a common way to do it. So you might want to find the properties of the dropper and detect that. You might want to look for an entry in the prefetch directory. Every executable that's run stores the path to the file there. One advantage to this is even if the executable is terminated and deleted, there's still an entry in the prefetch directory if it has been recently run. You could look for the name of the document. You could look for the browser history or DNS entries or metadata. These are all good indicators to detect it that do not require a file to still be persistent on the machine. All right, so again, you run your indicator on clean workstations and make sure that it doesn't trigger, and then you have to adjust it until you're not getting false positives. Our guest from Uber said you always want to get down to 0 false positives. You really don't want to waste your analyst time chasing down false alerts. So then make sure that you're seeing it and make sure that it's not burdening the server too much. If your collection script is too burdensome, then you will be creating a denial of service condition on the network, and that's, of course, not what you want to do. So if you have human leads, you got to document your statements. A technique for interviewing people is to not pressure them too much and not steer them too much. The best thing is to let them tell you what happened in their own words and record it. That way you'll get more what you want. All right. And if you're going to have to go outside your company, then you've got big problems because of confidentiality rules and people that are afraid of admitting mistakes that they might get sued for or be embarrassed. It's a problem. If you're law enforcement, you can issue subpoenas and search warrants and compel them to respond, but private organizations typically cannot. So unless you have something like a service level agreement with a provider that promises that they will deliver logs or let you audit their systems or something, which sometimes is the case, you might be out of luck. You can try to file a lawsuit just to get information. You might be able to use things like the Digital Millennium Copyright Act or cooperate with law enforcement to get information, but in practice, all these are difficult and slow. And so this is why a more experienced company will plan for this in advance by having a contract that gives them some access to the information they need in their cloud providers. And companies that are new to incident response will typically discover how blind they are and have to rethink their policies. You can file a subpoena in principle to get someone like an ISP to cough up the information, but again, this is expensive and slow and uncertain. And law enforcement might help you, but you often don't want to involve them. The one exception, of course, is child pornography. If you find child pornography, you are required to immediately report that to the Department of Justice. This was the #1 FBI law enforcement priority for the nation in the U.S. for years until, I think, 9/11, when the #1 priority was now terrorism. But it is still a really, really big deal, and you do not want to in any way investigate it or hold the evidence or impede an investigation, or you'll be guilty of a monstrous crime. So you just go to the Department of Justice website and report it, and then they will come take stuff and your investigation will stop in this regard, and it'll pass into their hands. You don't want to touch it. That stuff is radioactive. If you're going out of the country, without a country hosting sites, then of course it is very difficult to get data. The last High-Tech Crime Investigators Association meeting I went to, the Secret Service agents were very happy of the fact that they are getting cooperation from other nations such as Russia, where they request information and get it, and they did not appreciate me asking my question of, can you trust information you get from those people? Wouldn't they just be framing somebody they don't like for political reasons? And they said, oh, no, it comes with like an affidavit testifying to its validity, so we can use it in court, so it's fine. And I wasn't so convinced. But anyway, those of us that are not in federal law enforcement don't have much access to that stuff anyway. If, of course, you are in law enforcement, then you've got an interesting issue here, which comes up frequently. They can compel people to hand over data, and they can also compel them not to tell the customer that this has happened. And this is a huge debate, especially with the national security letters. So some of that is happening, but only your very largest companies or ones closely tied to the government are going to be doing that. Anyway, if you're going to work with law enforcement, then you have to maintain chain of custody of your evidence, document everything clearly, and convey everything in a clear manner to law enforcement. And of course, I think one reason that companies are reluctant to do this is then your own actions will become public to some extent and will be examined to some extent. So it's a big step that might involve a lot of unexpected consequences, and people don't go there lightly. There are organizations to try to help public-private partnerships like InfraGard that I'm in and other ones. where you get to meet law enforcement officials and talk to them about things and develop relationships with them. And this is something you must do if you're going to be a security professional, is have the ability to talk to law enforcement, to understand how they think, to have enough friends that you can call somebody on the phone. Because sooner or later, you will need to cooperate with law enforcement, and you have to get used to dealing with them. Like Microsoft, they have their own language and their own ideas, and you have to sort of get used to how they talk, which is also true of management. That's why you need certifications like the CISSP and the CISM. It means that you actually understand the role of these supervisory people, and you have a higher chance of communicating with them effectively instead of just hiding things from them and making yourself look guilty and confusing them and such. Anyway, we got some more Kahoots. There comes the sound, good. And here comes a chat message. What if a person works in a forensics company? Do they have to report to DOJ? If you find child pornography, you have to report it to the Department of Justice immediately, no matter who you are. Nobody else other than the Department of Justice is authorized to do anything about it. And if you don't do that, you'll be guilty of possessing it. So that's a big deal. Are there IR certs not from SANS? I just found out at this company, there is one from EC Council. And I wonder if it's any good. Let me bring it up on the screen, actually. I'll shove this to the side so people can still see it and join. And let me see if I can find it here. EC Council. Because they're teaching it here. And I didn't, yeah, there's an EC Council certified incident handler. So I don't know how good it is or anything, but they do have some EC Council IR search. So that might be a good thing to get. I know Certified Ethical Hacker does not have a lot of respect. The OSCP is considered much better, but especially in other nations and in the US military, a lot of people like these EC Council certifications. So they've got stuff like threat intelligence analyst, an incident handler and such, and even an encryption one, which is interesting to me. So these might be something to get. I just, I don't think a normal American company would take them too seriously, but I could be wrong. It's a good question. In general, computer forensics and incident responses got very few certifications, and there's nothing that's really big that everyone agrees about, like the CISSP, where you know you have to get it. There are also vendor certifications like FTKH and ENCASE Certified Examiner that are helpful, but there's not a general IR one that I know of. All right, looks like maybe we got everybody. I'll wait a few more seconds. All right, here we go. So Tripwire has an alert, but it's a false positive. So what's wrong with that? Yep, that's a failure of veracity. If it says something's wrong, but it's not really true that something's wrong. All right, every program and service in Windows is what? PE, portable executables. They are not all EXEs, some of them are DILs, and a few of them are COMs, but they're all portable executables. What network protocol is the easiest way to find malicious activity? Okay, that's DNS, of course. That's why the UK government is upset. It's so easy to tell what everybody's doing if they use the old-fashioned unencrypted DNS. All right. And what's part of the PE header? That's the import table that lists all the functions, the library functions that it uses from the Windows API. And that gives you a pretty good clue of the general activities that this function will perform. So I've got mhino twice. I've got WK, which I think is a real initials, and I've got dollars. They'll have to tell me who they are if they want their points. Maybe Abdul. Let's see, here comes a chat message. Yes, apparently from 5 minutes ago. Yep, oh, no. I'm not sure. DNS and network protocol. Yes, DNS is a network protocol used to resolve network requests. You can see it if you just run Wireshark. Every time you go to a website, it does a DNS request to turn that into an IP address. Abdul, that's what I thought. Good. So dollars is Abdul. Good. All right. And WK, I think that's a real name. I think my grader will figure it out. Are there any questions about anything? Well, I'm not seeing any coming in. Well, I guess that's it. I will stop the share, and I'll post a video of this. Here comes another chat message. Good. Thank you. Good. Wrote a more complete name. Good. Good. All right. Stay safe. Yeah. This place seems very safe. People seem quite peaceful out here. I'm not too worried. Although they did have a terrorist attack at this hotel recently, but there's security all over. Seems okay now. And I'll be back next week, so I'll see you all in San Francisco again. Have a good weekend. I'm going to stop the share, and I'll post this video. Farewell.